Hello, I'm Mohammad Saifullah Sheikh from SJ Government Polytechnic, working as a head of the department in machine tool technology. So I'm taking a subject that is called as statistical quality control. The main objectives of this subject is to know the basic knowledge of statistical quality control, and also to understand the basic knowledge of statistical quality control. The outcomes of this course is, after completion of this course, the students, you people are expected to learn about the understanding the basic knowledge of statistical quality control. So let me discuss about the quality. What exactly is a quality? The word quality represents the property of the product or the services that they are valued by the customer. Here, when you think about the quality, so the customer will think about the quality product. Always he thinks about the quality product. He thinks the product is good or bad. He thinks about the product, whether it is good or bad. So a statistical quality control, it is nothing but a system of maintaining standards in manufactured products by testing a sample of the output against the specifications. What product he will be there? So they will test against its specifications. That is called as the statistical quality control. It is a branch of mathematics used to summarize or analyze and interpret a group of numbers or the observation. It is called as a branch of mathematics because here we are using the statistics, whatever the data that we will obtain. So that data will be in terms of the number, and that data, with the help of that data, we are going to condense. It's a huge data. That data will be condensed in a homogeneous groups, and that data will be converted in terms of the charts. That's why mathematics is very important here. That's why in the mathematics, that too, it is a statistics we are using. That's why it is called as the statistical quality control. The statistical quality control is in term used to describe the set of the statistical tools used for the quality professionals. So statistical quality control, the pioneer of this is by Walter A. Stewart, Bell Laboratories in the early 1920s. Stewart develops the control charts in 1994, and the concept of the state of the statistical quality control. The statistical quality control has been categorized in three different categories. One is called as descriptive statistics. The second one is called as statistical process control, SPC, and then the acceptance sampling. So now we'll discuss all these three things in detail. So one is called as the descriptive statistics. Descriptive statistics are used to describe the quality characteristics and the relationship. Here, we are going to find out the quality characteristics can be found out once again by means of the mathematics and its relationship by finding the mean, mode, median, standard deviation. All many factors are there we are going to consider in the statistics. So that is called as the descriptive statistics. Then the second one is called as statistical process control, SPC. So the statistical process control, SPC, it extends the use of descriptive statistics to monitor the quality of the products and processes. So whatever the data here we are going to take from the descriptive statistics, Like as I've told you that it is a mathematics, in that mathematics it is a mean, median, mode, and all this, the standard deviations, and there are so many parameters are there. So that we are going to take it here. That's what it is said as extend the use of descriptive statistics to monitor the quality of the product and the process. The second point in the statistical process control is that a statistical process control helps to determine the amount of variations. The the example for this, the amount of variations in the data is nothing but when during the manufacturing of the product, and after the manufacturing of a product, the inspector, when he determines, when he goes for the inspection, so he will find out, he will measure the dimensions of the product, and if he gets the dimensions where there may be sometimes, because of if the process is not under control, so then the dimensions of the components will vary. So that variations here he is going to obtain. So with the help of the statistical process control, okay, we can get to determine the amount of the variation. Next, the next point in the statistical process control is that to make sure the process is in the state of control. That's why. So the second point itself says that when you determine the variations in the product, immediately, if there is a variations in the product, immediately, immediately there will be corrective actions. When you take the corrective actions, so then we can bring the process in a state of control. So here there is a link between the second point and the third point. So then the next point of statistical process control says that no two items are exactly alike. There will be no two items are alike in the sense when you produce the components in a machine. So what will happen? So when you measure the dimensions of the component, so there is a variation. So because of that variation, here we are going to say that no two items are exactly alike. Both the items, when you compare, when you inspect many number of the products after the manufacturing, so they will be having different dimensions. So that is what it is called as the variations in the product. Next point in the statistical process control is that some sorts of variations in the two items is bound to be there. Always, in fact, it is an integral part of any manufacturing process. So the last point, as I've explained, that there is a variations. No two components will be of uh, similar types because there will be a variations. So some sorts of variations in the two items is bound to be there. So there will be the variations, and there is, this is a fact that it is, because of that variations, always there will be a variations in the manufacturing processes. There will be a variations in the dimensions of the product during the manufacturing. So the next point in this difference is the characteristics known as the variations. So the way the whatever the difference of dimensions that we'll get after the manufacturing of the product, that is known as the variations. So this variation may be due to substand, substandard quality of raw material, careless on the parts of the operator, fault in the machinery system. So as I've told you that the two component will never be having the same the dimensions. So it is because that if there is a variations in the standards of the qualities of the material, so it is very difficult to manufacture a product, a very good quality product precisely. I can say that. So there will be a fault in the material. That is a one point. The second point is carelessness on the part of the operator. Sometimes the operator, if he is having a negligency during the production processes, operations, so there is a chance that we may get the variations in the products, and then there is a fault in the machinery. If you don't if you don't maintain the machineries, so naturally there will be the faults in the material. Sorry, there will be faults in the product. That is nothing but there will be a variations. We are going to get the variations in the products that has been manufactured, even if the machinery is not in a proper condition. So these are the factors that we are going to consider. So in the second part of the statistical quality control, that is called as statistical process control. And the third one is the acceptance sampling. So the process, the the process of randomly inspecting a sample of good and deciding whether to accept the entire lot based on the results. So it means that, so when you take the part, when you study the acceptance sampling, in the acceptance sampling, a machine, we are going to consider this acceptance sampling in the mass production, especially in the mass production. So during the mass production, a machine, it is to give hundreds, thousands of items per hour, and it is not possible for us to inspect all the items. In such cases, depending upon the agreement between the customer and the producers, so they will come to an agreement that you select, the customer will say that you select a few items randomly. Okay, you select some few items randomly as a sample, as a sample, and decide. Depending upon that, we will decide whether the whole lot has to be accepted or not. So for example, say there is a lot of 100 items here in this, and out of that, the customers and the producers, they will come to a conclusion, to the conclusion, saying that a sample will be, say, of 5 items. Out of these 5 items, if there are 3 good items and 2 bad items, so then the customer will say that, if when you inspect 5 items, out of the 5 items, if there are 3 goods and 2 bad, I am going to accept it. So on that basis, what will happen? They are going to have the agreements, and the process will be continued. And because of this, there is a chance that, so there will not be an 100% of inspection here. Here only the sample will be inspected, and the number of the sample is totally depends upon the agreement that has been taken place between the customer and the producer. So that is called as the acceptance sampling. So the next point is the multiple choice questions here. So the first multiple choice question says that process control is carried out, process control is carried out before the production, during the production, after the production control, all of them above. A process control is carried out, so it is during the production process. When there is a production process, at that time, so it will be, the process will be controlled. So the answer for this is B, that is called as during production process. The second multiple questions here is that statistical quality control method are extensively used in the industrial production process because of there are 4 options: reduction in cost, greater efficiency, timely detections of the fault, all of them above. If you take all these 4 options, one is reduction in cost. Naturally, when you go for the acceptance sampling here in the mass productions, so there is a reductions in the cost, because there is no 100% inspection will takes place. So that's why the cost of inspection will be less. As the cost of the inspection will be less, so there will be the cost of the product will also be less. And here, as we have seen SPC, that so all the machines before the productions of any component, all the machines will be has to be we have they are going to maintain it properly. So because of the proper maintenance of the machines, so there is a chance that we will get a greater efficiency, higher efficiency in the machines will be there. And because of this higher efficiency, we are going to get the quality product. And during this process, so there is third point is that the namely timely detections of the fault. As we know that, so during the process, if the process went wrong, so as soon as the process, we are going to inspect the component. And if there is a variations in the dimensions of the components that has been manufactured, and when it has been inspected, so during after the inspection, immediately the inspector will inform the operator that the process is not under control. So then he will make the the operator will take the necessary steps, and he will bring the machines into control, so that so that the proper products with a quality with the quality can be obtained. So that is what is called as timely detections of the fault. So that's why all these three above, that is the reductions in the cost, greater efficiency, timely detections of the fault. So all these are included in the statistical quality control method. They are all the methods. That's why the option for this multiple choice question is the D. So then the third question, the three basic elements of quality systems to have a quality product. The three here has been an A, B, C, D. Four options has been given. I will just go through the A. A is quality management, purchase, and document control. If you see the option A, quality management, it is okay, but purchasing will not come under the quality. That's why the option A is the wrong option. I'll go to the B, option B, quality management, okay, quality control, okay, quality assurance, I don't think that, quality assurance will be the right options. Then the third one is SPC, statistical process control. It is there, inspection is there, and and the quality assurance is there. So the third option is the right options. And the fourth option is quality control, quality cost, and quality charge. So that is the wrong answer. So for the third multi-choice question, the three basic elements of quality systems will be the right answer is SPC, inspection and quality assurance. So then the fourth one is, which of the following is multi-choice question? Which of the following is the most important element in statistical quality control? So there are four options are there. One is the feedback loop. The second one is make operation. Third one is inspection, and then quality of the incoming material. If you see all those things, which of the following is the most important element in statistical control? So feedback is not that one. Make the operation, there will be the operation, there will be the inspection, and there will be the quality of incoming material. So the inspection will be taken place after the manufacturing of the product. If the incoming material is a quality material, so naturally we will get the good solid products, the quality products we are going to get. So that's why the inspection is not the the most important. So I can say that the quality of the incoming material is important. That's why the the options for this question, which of the following is the most important element in statistical quality control? It is the quality of the incoming material. So we are referring, I have referred here the two books that is called as Statistical Quality Control by Douglas Montgomery, and the second one is the Quality Control by M. Mahajan. So this is the first session. So uh, here I have completed. Thank you. So there is a description questions on this first session. You can explain the statistical quality control. So here, uh, this the for the explanation of the statistical quality control, first you need to define quality, then you need to define control, then you defined quality control. Then after that, you defined statistical quality control. So if I go for the explanations of the explanations for this descriptive questions like statistical quality control, I will define a quality. Quality is what best to use. So for the customer, he will think, in terms of the good or bad. So that's why a quality products should be there for the customers. Customers need a quality products during the manufacturing process. In industry, in industry, a quality product is one that fulfills the customer's expectations, and the expectations or the standards of performance are based on intent use intend use here. So it is all depends upon how you are going to manufacture, and depending upon the uh, manufacturing processes, the the quality of the product is totally depends upon, I can say that the quality of the product is totally depends upon the manufacturing processes. You need to bring the process under control so that you can get the quality product. So what is then you can explain about the control. What is a control? So during the process, as I have told you that, so when the manufacturing process starts, so the as soon as the product is obtained, when we obtain the product from the machine, so there will be an inspector. So he is going to inspect the product, and if there is he will find out the variations in the component, and he will compare that variations with the standard one. And and once if he achieves if there is no variations when he compares with the standard one, so then he is going to say that so there is a quality product. And as soon as if there is a variation, if the variations in the dimension starts, so naturally the inspector is going to inform the operator that the machine is not under control. So once the operator gets that news as soon as feedback, so he will try to bring the process under control by taking the feedback from the inspector. Then the word comes, that is the statistical. It is a statistical is nothing but it is a data. So the data is obtained, and the data will be it's a huge data, and so that huge data cannot be kept as it is. We need to condense them into a homogeneous group. So and then we need to convert that data in terms of the charts, and that charts will be pasted on the machine. So when you paste that charts, the data that is obtained, statistical data that that we are going to obtain, it will be pasted on the machine. And as it is pasted on the machine, the operator, whenever the machine goes out of control, he will go through that chart and he will correct the process, so that the ultimate aim is to get the quality product, so by means of controlling the process. So that is called as the statistical quality control. Thank you.